Hello and welcome to New Scientist Weekly. This is the show that brings you our selection of the essential stories of the week. I'm Rowan Hooper.
And I'm Penny Sarche. This week we're joined by New Scientist journalist Leah Crane in Chicago, Carmela Padovich-Callahan in New York, and we've got Michael LePage and Madeline Cuff in London. Woo! Welcome all.
Hello.
Hello.
Yeah.
Hello.
As you'll hear, we've got a very groovy new theme tune. How about that?
Yeah, it's great. New sounds, but same great show.
Yeah, new sounds and new vibe. Right, coming up on the show this week, we're hearing about a new way of getting quantum computers to run programs that should be too big for them. And we're predicting the future with iconic comic book hero Judge Dredd.
We're also hearing about the earliest evidence for bows and arrows ever found in Europe and the plan to raise the elevation of the Maldives as sea levels rise.
That's coming up, but we're going to start with a story that on the face of it is about life on Mars, but it also says a huge amount about life on Earth. So the story is about astrobiologists who've been testing scientific instruments on samples from the Atacama Desert in Chile. Leah, you've been reporting on this, and like the instruments they're using and the samples they're testing, and both are important parts of the story, aren't they?
Yeah, so let's maybe start with the instruments.
Yeah.
They're using two sets, really. One set are sort of state-of-the-art laboratory instruments that any geology lab on Earth would have. And the other set are instruments that are exact or almost exact copies of the instruments that are on Mars right now and the ones we're about to send up there.
And what about the part of the desert that we're looking at? Because I saw some photos of it. And at first I thought it was Photoshop because it looks so much like Mars, but then there's blue skies and clouds above it.
Yeah, the researchers actually also sent me one where they have photoshopped the blue sky to red. And my whole brain was like, that's Mars. That's clearly Mars. So it's this area in the Atacama Desert that is maybe one of the most Mars-like areas on Earth. Partially just because of the geology that they have there, because they have this sand that has all these minerals that are consistent with Mars. Also, this particular area has a lot of hematite in it, which is the same mineral that gives Mars dust its rusty reddish color. And this area also gets a lot of UV radiation. So it's very similar to Mars, not just in pictures, but also in geology.
And so the idea is to use with what we've got on Mars to test what it can look at, what it's able to look at. But like the ones we've got on the landers and on the rovers up there at the moment, they're designed to look for evidence of past life, right? So does that mean to look for sort of, fossilized DNA or, fragments of organic molecules that we know are associated with life on Earth?
Yeah, exactly. They're basically looking for anything that indicates life might once have been there, might once have been eating stuff, all the sort of surrounds of life, and also fossilized actual life is what they're ostensibly looking for. The problem with that being these new tests in the desert are showing that those instruments might not actually be sensitive enough to find anything, even if, like in the Atacama Desert, we know that it's there.
But there's another angle to this story that I thought was amazing, and that's that when they use the state-of-the-art equipment on the stuff from the Atacama Desert to analyze all the samples, they found loads of evidence of life, didn't they?
Yeah, a lot. They found up to 1 microgram of DNA per gram of soil, which is a very small amount for anywhere on Earth. But they said, I believe that garden soil would have 1,000 times as much. So it's really not that much, but it's a lot for the driest, oldest desert on Earth. And that little microgram of DNA included DNA from 19 species of bacteria and 2 fungi, which is interesting. The even more interesting part is that nearly half of all of that DNA didn't match anything in the genetic databases that we have.
Wow.
So, yeah, it's sort of nuts and something that I was really shocked by and the researchers were sort of nonchalant about. They referred to those DNA samples as the dark microbiome, comparing it to sort of dark matter. We know it's there, but we have no clue what it is. And what it means is that these could be organisms that just haven't previously been discovered. We just haven't seen them anywhere yet. Or that they're relics from organisms that lived hundreds of millions of years ago in that area.
Well, there's almost certainly both, aren't there? There's like known unknowns, but there might be things we don't know of at all in there, especially in richer ecosystems, like you say. If we really looked at them, you're going to find stuff that we didn't know. So unknown unknowns will be there as well. But this study from the Atacama I love this because it just shows, I think it just shows a great hint of what's out there.
And Leia, are some of the sort of planned rovers or future missions going to have more sensitive instruments to hopefully find some signs of something interesting up there?
Well, so the bad news is that these researchers did test the instruments that we plan on having on those rovers soon, and they didn't do much better than the ones that are up there right now. The good news is that lots of different space agencies, but particularly NASA and the European Space Agency, are planning to do sample return and bring back samples from there so that we can use the good stuff that we have in labs down here.
Now, Michael, you've been reporting on the oldest arrowheads ever discovered in Europe.
That's right, we've discovered arrowheads in what is now France that are 54,000 years old. So that's older than any discovered outside Africa before. In Africa itself, we've found even older ones that are 70,000 years old. So it's likely that bows and arrows were first developed in Africa, but these are the oldest outside there.
Wow, so where have they found them in France?
Yes, so this was a rock shelter in the south of France that was used first by Neanderthals for tens of thousands of years, and then from around 45,000 years ago by modern humans. But the extraordinary thing is that they found there was this 40-year period around 54,000 years ago where it was occupied by modern humans. So it seems there was this little group of modern humans that made it into Neanderthal territory and stayed there for 40 years and then just disappeared.
So is the new finding then that these modern humans who were briefly there had bows and arrows?
Exactly. So they've been going through the layers from that 40-year period, and a researcher called Laura Metz and her colleagues, they've found more than 1,000 little stone points. And they've also shown that around 100 of these stone points have signs of impact damage. So basically, these were arrowheads.
Wow. And can we be sure? How sure can we be of findings like this?
Well, what she did to sort of demonstrate this is she made her own arrows with stone points just like the ones they found in this cave, and then she went and shot them at the carcasses of animals. So looked at them and analysed the impact damage, and so she's shown that the type of damage on these points is exactly the same. So it's pretty conclusive evidence.
That's the sort of lab work I want to do.
Yeah,
make your own arrows and fire them at carcasses of animals.
Experimental archaeology. It's called.
Yeah, amazing. You're talking about them as if they, were only used for hunting animals, but do we know if they might have been used by this band of plucky humans to fight off the Neanderthals around them?
Yes, of course. I asked that question, and we just don't know is the answer. The team haven't found any evidence of conflict at all. But we definitely know that Neanderthals were there at the same time, because they've shown that actually this cave was occupied by Neanderthals just a year before the modern humans moved in. So they would almost certainly have come into contact. And you can imagine that it does seem quite likely that there would have been conflict between them, and that, the modern humans would have used their bows and arrows, but we just can't say.
No, sure.
There's been quite a rethink in recent years of Neanderthals, because we used to think they were kind of stupider, but now we know they had sophisticated culture and maybe had art. Would they have used bow and arrows at this time too? Do we know?
Well, that's the surprising thing, is we now know that they presumably saw these modern humans using these bows, so they must have known about them, but they never developed bow and arrow technology themselves. At least there's no evidence of that. They seem to have kept using these quite large spears with big spear tips, and these spears would either have to be sort of thrust directly into animals or thrown from quite a short distance. And so they never really developed the same kind of technology as these modern humans had.
Let's take a quick break to tell you about the second event in the new series, The Greatest Physics Experiments in the World.
Yes, the event is Fermilab, solving the mysteries of matter and energy, space and time. Just the mysteries of matter and energy, space and time. Join Fermilab senior scientist Don Lincoln as he explains how America's flagship particle physics facility has taught us so much about our universe and how it works.
This is an online event. It's taking place on the 4th of April. Go to newscientist.com/Fermilab to find out more. Next up, we have a story about small quantum computers possibly doing big things. But first, let's back up a bit and remind ourselves what quantum computers actually are. Carmela?
Right, so let's try and keep this somewhat simple. In a conventional computer, we use bits, and we use bits to process and store information, and these are your ones and zeros. And you can kind of think about the ones and zeros being switches for electric current. So 0 means no current, 1 means that there's some electricity, and the electricity is going through some tiny bit of some tiny chip inside of your machine. And when we want to go quantum, instead of using regular bits, which are ones and zeros, we go and we use quantum bits, which are called qubits. And because the qubits are made of quantum states, which are in general much stranger than any sort of on and off switch that you may usually encounter, these qubits can be in the state corresponding to 1, in the state corresponding to 0, but also a bunch of states that are sort of both 1 and 0 and also neither 1 and 0 at the same time. And I understand that this sounds completely bonkers, but it's real. Researchers have actually been making qubits for quite a few years now. We know how to do this in practice. And because qubits have all these extra states compared to conventional bits, researchers have for a very long time, even before they could make qubits, have been arguing that, you could store more information, you could process more information with qubits, which should eventually make it possible for quantum computers to solve problems that classical computers just can't handle at all.
Your story for us this week is about running machine learning programs on quantum computers. And so that certainly sounds like complicated, quite sophisticated programming.
Yeah, exactly. I mean, so that was sort of the punchline, right? These machine learning programs are really complicated. And the research that I reported on was really about finding a method to take these big, complicated programs and sort of do tricks to make them smaller and make them not overwhelm like very small quantum computers that we have now. Quantum computer programs are these sort of special lists of instructions that are called quantum circuits. And I reported on a method by which you take your circuit and you cut it into smaller sub-circuits. And even if the original circuit is too big, the sub-circuits can be small enough to be run on a realistic machine. And then the researchers sort of pushed it a step further, and they figured out that you can throw out some of the sub-circuits. So now you're not only using fewer qubits, but your computational time is also shorter because you're not running a bunch of sub-circuits. And, I'm making this sound really simple. And in reality, it takes so much math and other sophisticated methods to figure out when you can actually throw out a part of a program and not incur some really big error. But they sort of figured out how to do it in a systematic, methodical manner and try it out on some problems.
So they've got it to work for 2 different kinds of machine learning programs, right?
Yeah, so the researcher I spoke to, they didn't use an actual physical machine. They simulated a small quantum computer with 8 or 5 qubits, which is very little. And they ran 2 different programs, one that could learn how to recognize handwritten digits, and one that could actually sort of predict what a real quantum computer would do to some set of data. They could actually predict, it could actually learn how to mimic a real quantum process on a bigger machine. And in both of these cases, they programmed or they sort of formulated the machine learning problem in such a way that if you just looked at it, if I just gave you a sheet of paper and I was this is the program, how many qubits do you need? You would be oh, I need 64 qubits or I need 10 qubits. And in either case, they didn't need that many. In fact, the 64 qubit problem, they did it with 8 qubits because their circuit cutting and throwing out method reduced it so much.
Does this mean that we're getting closer to useful quantum computing? We don't actually need to focus on building bigger and bigger quantum computers?
So really the stage of quantum computing development that we're at right about now is sort of early enough that researchers feel like they need to push on both the hardware side and build bigger and better machines, but also sort of push the limits of what algorithms and programming can do on the sort of computer science side of things, which is very exciting. It shows that quantum computing is at the point where we can talk about not just hardware, but also almost quantum software, which we definitely couldn't do 5-10 years ago. It feels like this is a new thing that we're doing.
Now, in the bonus episode of the podcast that went out a few days ago, I was reporting from Venice about the barrier they've built there that cost €6 billion to protect the city from sea level rise. And Maddie, You've got a story this week about, well, it's not the similar project, but it's a way to try and protect the Maldives from sea level rise.
Yeah, that's right. So usually when you think of the Maldives, you probably conjure up an image of an idyllic white sand beach, probably fringed with some palm trees. Exactly. And I have to admit, when I was reporting on the story, I went down a Google image search wormhole of just gazing at resorts on the Maldives and planning a fantasy holiday. Yeah. But unfortunately, the reality of the future of the Maldives might be slightly less idyllic. So the future of this nation is really in the balance when it comes to sea level rise. So the Maldives has got more than 1,100 separate islands. And maybe that might need to be, the population that live on those islands might need to be condensed down into kind of 2 artificially raised islands that are filled with high-rise apartment blocks and skyscraper offices if the nation is to survive rising sea levels.
Yeah, because like most of it is under sea level already, isn't it? It's already got the lowest terrain of anywhere in the world. So, yeah, I guess they're going to have to. So they already have been building up higher elevation, haven't they, by sort of artificially, a bit like they do in Holland, like by literally creating new land.
Yeah, so work is already underway in the Maldives to try and kind of protect the nation from rising sea levels. So they're already, like you say, building new islands by pumping sand from the sea floor. And the biggest project of this kind is an island called huddle, excuse my pronunciation, which is next to the island capital of Malé, which is a really, really overpopulated, tiny island, which holds hundreds of thousands of people and is really, really crowded. And it kind of looks like a Manhattan in the middle of the Indian Ocean. And so they needed to create some more space next to Malé for potentially population overspill. So work started back in 1997 to create this new island, which is built 2 meters above sea level, so at least a meter higher than most of the rest of the Maldives. And despite measuring just 4 square kilometers across, Huala is already home to more than 90,000 people. So that really shows that demand is there for kind of new, higher islands for people to live on.
What, so those 90,000, did they sort of pay their way to the front of the queue, or were they sort of shoved onto there because they've made these new sort of high rises for them?
It's a bit of a mix, to be honest. So there's some kind of luxury apartments where the rich Maldives residents would choose to live to get a bit more space. But there's also some social housing available on the island for people affected by disasters or who have already been displaced from their own islands by rising sea levels. Right. So the story that I was reporting on was about some new research by Maldivian scientists in collaboration with the University of East Anglia, and they have essentially calculated that the entire population of the Maldives, which is more than 500,000 people, could live on just 2 heavily built up islands raised in this way. So alongside Huala, you'd need a second island, which would probably need to be raised even further above sea level, maybe up to 6 meters above sea level, to kind of protect against future sea level rises that we'll see in the coming decades.
And who's paying for this? It's literally rebuilding the country, isn't it?
Yeah, and I mean, unsurprisingly, it'd probably be pretty expensive. I imagine the costs this is a kind of very concept stage plan at the moment, but the costs would run into hundreds of millions, if not billions of dollars to do. So there is an argument for kind of concentrating a lot of the population onto a smaller number of islands, because it makes things like providing basic infrastructure and services like clean water and sewage networks and food much easier and cheaper to do, rather than having your population spread out over lots of islands. But still, this is a kind of a huge endeavor for a country like the Maldives to try and embark upon. And it's not really clear who would pay for it. So in the past, the Maldives has taken loans from China before to build infrastructure projects under China's Belt and Road Initiative. And it's also recently struck deals with countries like Saudi Arabia to kind of develop islands. But there's also probably an argument to say that you could get the money from international climate finance pots. There's lots of kind of pledges to say that richer countries need to help developing nations cope with the impacts of climate change. And this is very clearly a really kind of existential climate impact that the Maldives faces.
It's a fascinating story. Thanks, Maddie. We'll put a link to that in our show notes. It's time for the SciFi Alert, which is when we report on things in science that have already been predicted in science fiction. And Rowan, you have a special segment this week.
Yes, so you might or might not have heard of the British comic 2000 AD. For 46 years now, it's been telling stories about the future, and one of its greatest creations is the brutal future police officer Judge Dredd, who patrols the streets of post-apocalyptic America in a city called Megacity 1. And Judge Dredd is the subject of a new book by Michael Mulcher called I Am the Law, How Judge Dredd Predicted Our Future. Mike is a comics journalist and a brand manager for 2000 AD, and he joins us now. Welcome, Mike. Thanks for joining.
An absolute pleasure, Rowan. Thank you for having me.
Now, for people who are new to this, can you give us an intro to Dredd and his world?
Okay, 1977, John Wagner, Scottish-American writer, and Carlos Esquerra, a Spanish artist who worked in the British comics industry, came together to create this hyper cop, the ultimate lawman of the future, who roars around on a massive motorbike in, as you said, a post-apocalyptic America, a hyper-urbanized America, 800 million people living in the ruins of the old world, to quote the 2012 movie. He has the power to dispense justice on the spot, so fining people, jailing people, shooting people at will. And the idea of the book is essentially to look at how John Wagner, Carlos Esquerra, other creators such as Alan Grant, Pat Mills, Brian Bolland, Mick McMahon, were so prescient in how they viewed the greater processes of technology, of politics, specifically law and order politics, that have remade our world. And when you read the old strips from the early 80s especially, it's actually quite terrifying just how much they got right. And not just about the technology and the kind of ephemera of urban life, but the underlying rationales and justifications for hardline policing.
Yeah, well, because there's two ways of looking at it, aren't there? There are the sort of the straightforward technology and science that exists in Dredd's world that we see now, and like riot foam is one that springs to mind, but other sorts of and the way robots are portrayed in it. And that we have robots now more and more similar to the ones we see in Judge Dredd. But there's also, as you say, the sort of societal predictions and the reflections of our society that it makes. So can you talk a bit about, both those things?
Sure. Yeah, so, I mean, there's the kind of the surface level predictions, smokatoriums where smokers have to wear a big bubble helmet to have a puff, sugars banned, coffee's banned, you've got fake meat, you've got recyc, which turns dead citizens into useful products.
We don't have that yet, though, do we?
Well, I mean, not yet, but of course, whenever there's a new push to compost human beings with the kind of eco funerals, somebody tweets the 2000 AD account going, look, it's recycled, it's recycled, which you realise. But also, as you say, there's something broader than that, which is the politics that underlines all of this, which rose up in the 1970s. And Dredd is both a consequence of and a reaction to that kind of tough on crime, law and order politics that arose in America in the late 60s and kind of took over Britain in the 1970s. And it's a process of securitization where everything becomes an issue of security. So, you hear people talk about climate security and food security, and war becomes an issue of policing in effect. So the way I describe it in the book is the vision of the judges as controlling this vast city that runs down the eastern seaboard of the United States. And they control everything from welfare to warfare, because all of this plugs into their mission of the war on crime. Of course, crime never ever goes away, but they are inextricably linked to this kind of hyper urbanization, an incredibly surveilled society where your every move is recorded and can be used against you, where even the slightest slip can result in death, either by accident or at the hands of the judges.
That was Michael Mulcher talking about his new book, I Am the Law, How Judge Dredd Predicted Our Future.
That's all for this week. Thanks to all our guests and thanks to you for listening.
Do go ahead and subscribe and get in touch on Twitter @NewScientistPod. Say hello, give us any feedback you like, and do subscribe. And we'll see you next week. Bye for now.
Bye.
Bye.
This podcast is produced by OG Podcasts. Find out more at ogpodcasts.co.uk.